Hi all, it's Richard. My camera's still red, so but my screen is in front of me, so I'll be looking forward. But um, today I'd like to elaborate more about the TFIDF method that our group used for the Trump tweets. So TFIDF, like we stated in the presentation, it means term frequency and inverse document frequency. So we can break down how we calculate this into two parts. So the first part is TF, aka term frequency. So this is essentially the count. If we look at this formula here, it is the count of T in D divided by the number of words in D. Um, so basically, we're taking the count for our, in context of our data set, we're taking the count of a certain word in our tweets. So our tweets would be our documents, and then divide that frequency by the number of words that are in that specific document. So that would give us our term frequency part of the equation. So the IDF part comes from, or inverse document frequency basically tests how relevant the word is across all the documents. So for example, a word might be super frequent in one tweet, but if it's not present in all of those tweets, like across all tweets, then it's definitely not going to be weighted as importantly. So basically what we're doing is we are doing, to calculate the IDF, we're taking the number of documents. So the number of documents n, so this is the number of tweets in our case. If we just focus on our flagged Trump tweets, that'd be 304. So we're taking 304 tweets divided by the document frequency of a term, which basically means how many documents does a certain word appear. So for example, if we have a word like rigged, and rigged appears in 20 tweets, then our document frequency of the term rigged would be 20. So that's how we would calculate our IDF for a given word. So yeah, so n divided by the document frequency. So the number of documents divided by the document frequency, and that gives us our IDF. And then we also want to take the log of that, because the log kind of makes it on a more narrow range, because if we do not have that log, then these values of n divided by df are just going to be massive if you don't have like a very rare word that appears only once, and then that's just going to be a massive score that throws everything off. So it's kind of like a scalar of sorts by using log. And then TF-IDF is basically multiplying the term frequency we talked about, and then the IDF, which is the inverse document frequency. So if we come over here, this is the code I actually use to calculate the TF-IDF scores for our data set. So this is using Python. Sorry, R individuals, I don't know if I could replicate this in R, but you see here, I basically just read in my CSV file. There's basically, well, it's in the name, it's read CSV, and then I'm indexing my data frames by is flagged and not is flagged. For the sake of this teaching video, I'm only going to use the is flagged data. So yeah, to use TF-IDF on Python, basically what you got to do is from the sklearns, or the scikit-learn library, you want to have the feature extraction module, which is this, and then you want to import the TF-IDF vectorizer class. And basically, the TF-IDF vectorizer it vectorizes the TF-IDF calculation across every single word in like all of your documents and stuff. So that's really nice. But the issue with our data is we did do preliminary analysis on it, and the issue is that Trump's data, he likes to use a lot of like random words that don't make sense. He likes to like put in links. Obviously, links um they aren't what we want to be looking for the sake of our analyses. So what we did here was we have custom stop words, so aka words to look for and kind of remove from the data. So we have like TCO, HTTPS, HTTP, retweet, AMP, www, all that fun stuff. And we're combining that over here, combine. We're combining it with a list of stop words from the stop words from the TF-IDF vectorizer. Yeah, what we're doing, we have a combined stop word list. That's what we're filtering out when we run the TF-IDF vectorizer. So right here, I'm basically initializing that vectorizer to do its work. So what I'm doing is I'm adding the stop words for it to look for, the combined stop words. I'm implementing a max features count. So this will find 3,000 terms, like words / phrases that have like high TF-IDF scores. And then n-gram range basically means, so this can search for either one word things such as like rigged, two word things such as rigged election, and then 3 word long things such as, I don't know, Pennsylvania voter fraud, something like that. Basically, and then when I run result, I'm running this model on the data we have, which is our flagged pre-2021.text, so the text column. And then here, I'm just listing the keys out. I chose not to print them here because there's 3,000 of them. But here, I'm printing I print the first 30 words and their indexes for you. I'll get into it in a bit. And then also printing a lot of stuff. So if we look at down here, we have the words and their indexes. So basically, when we go down to the scores, the word corresponds with this index. So if we look over here, for example, these are our TF-IDF values. So the left-hand side of the coordinates, so like the zeros and the ones, these are the documents that these words are in, and then the right side is the word that it is. So for example, 0, 2,598, this would be document 0, so the very first tweet, and then the word would be 2598, it lines up, it would be the word Nevada. So the word Nevada has a TF-IDF score of 0.2497, yada, yada, yada. And yeah, so this basically does it for every single word for all 304 tweets. So if I put the TF-IDF values in the matrix, but it doesn't show because the values are small and there's a lot. But if you look here, I printed out the dimension of the matrix, and basically this is 304 rows, which means the 304 flag tweets, and there's 3,000 columns, which each column would represent a different feature of our a different feature presented by like all this stuff, the TF-IDF values.